Se van a ir conectando mediante Facebook. Ahora sí, ingeniero Bedri, puede iniciar.
Bueno, muy buenas noches a todos los colegas presentes que están conectados de manera virtual, también a todo el público que esté interesado en escuchar esta conferencia, esta charla del doctor Fabricio. Eh, Quiero dar la bienvenida también y la apertura a esta charla que corresponde al ciclo de conferencias por el centenario de la Sociedad Geológica del Perú. Eh, Nuestro saludo muy especial y de confraternidad a nuestros colegas presentes, la doctora Elisa Soares Rocha, quien es actual presidenta de la Sociedad Brasileña de Geología. La doctora Elisa Soares tiene una licenciatura y un doctorado en geología de la Universidad de Brasilia y es profesora de mineralogía en la Universidad Federal de Goiás, Brasil. Su interés de investigación es la mineralogía, geoquímica y petrología del magmatismo alcalino y carbonático y sus mineralizaciones primarias, así como su aplicación como fuentes alternativas de fertilizantes para agrominerales. También contribuye con acciones de patrimonio geológico y geoconservación a través de proyectos educativos, utilizando métodos prácticos para la divulgación científica. Este será un tema interesante que en su momento podremos conversar, doctora Elisa, a propósito del tema del patrimonio geológico y de geoconservación. Podremos tener alguna otra sesión más adelante. Un gusto de tenerla con nosotros, presente en nuestra conferencia, a propósito de nuestro centenario. También quiero saludar y presentar al doctor Fabricio de Andrade, quien es actual profesor de la Universidad Federal de Minas Gerais, Brasil, y coordinador del Laboratorio de Cartografía Geológica, Geotectónica y Geodiversidad de la misma universidad. Voy a leer algo más sobre el doctor Fabricio. Es vicecoordinador del Instituto Geoatlántico y miembro votante de la Subcomisión de Estratigrafía Criogénica de la Unión Internacional de Ciencias Geológicas. Sus siglas son IUGS. Su principal interés como científico es interpretar los registros de las antiguas condiciones tectónicas, químicas, atmosféricas, geográficas y biológicas del planeta y las retroalimentaciones entre todas estas esferas, la coevolución entre el planeta Tierra y la vida en su superficie, y cómo nosotros, los humanos, seres humanos, pueden afectar estos ciclos naturales y viceversa. Ha sido investigador visitante en varias instituciones como la Universidad de Stanford, Universidad de Leeds, Universidad de Australia Occidental, Universidad de Copenhague, Universidad Curtin, entre otras. Entonces, damos la bienvenida al doctor Fabricio, quien va a dar la charla y su presentación titulada Geología de Brasil en el contexto de la plataforma sudamericana. Quiero aprovechar que está ya conectados colegas de Brasil, probablemente otros países también, y de Perú, y quiero aprovechar esta oportunidad para compartir con ustedes sobre las actividades que tenemos este año 2024, que celebramos el centenario de nuestra Sociedad Geológica del Perú. Estas actividades son la Semana del Centenario, que va a celebrarse la primera semana de julio, a los cuales están invitados a participar a todos los presentes. También tendremos la participación conjunta entre la Sociedad Geológica y el Colegio de Ingenieros del Perú para la celebración de la Semana Geológica, que va a ser en septiembre. Más adelante, nuestra institución también va a desarrollar el proyecto, el programa Congreso Peruano de Geología. Esto va a ser la primera semana de diciembre de este año. Entonces también a todos estos eventos y actividades, por favor, vamos a invitarlos de manera presencial y virtual para que puedan participar con nosotros si están interesados en nuestros eventos y también en las charlas correspondientes que vamos a tener. Eh, en este ciclo de conferencias por el centenario que estamos organizando, quiero mencionar también que más adelante vamos a tener más participantes, más doctores, más profesionales que van a apoyar una vez por mes en charlas adicionales y será motivo para que puedan juntarse y también conocer sobre la realidad geológica actualizada de otros países a nivel Latinoamérica. Muchísimas gracias a la participación de la Sociedad Geológica de Brasil y también a la doctora Elisa Suárez, al doctor Fabricio de Andrade y a la doctora Nelly Palermo, que están conectados como panelistas en esta conferencia. Muchísimas gracias por su participación.
Gracias.
Entonces, empezamos con la disertación, con la exposición del doctor Fabricio de Andrade, por favor, sí. Aunque creo que entra primero la doctora Elisa, con sus palabras y una breve presentación, es lo que entiendo. Muchas gracias.
Sí, muchas gracias. Buenas noches, señor Bedrick Mori. Y buenas noches a todos los presentes. Es un grande placer estar aquí. Soy Elisa Rocha Barbosa. Atualmente presido la Sociedad Brasileña de Geología y en nombre de esta institución agradezco la invitación realizada por la Sociedad Geológica del Perú. Es un honor tener la oportunidad de celebrar el primer centenario de esta institución dedicada al servicio de las ciencias de la Tierra. Sabemos los esenciales que fueron, son y serán siempre las ciencias de la Tierra. Y para que las civilizaciones y los seres vivos permanezcan y prosperen en nuestro planeta. Tenemos grandes desafíos, incluida la situación catastrófica que estamos viviendo con las inundaciones en el sur de Brasil. Entendemos que es nuestro trabajo apoyar soluciones dignas y coherentes con el siglo que vivimos. Felicitamos la iniciativa de la Sociedad Geológica del Perú de reunir las entidades hermanas en torno de esta celebración para unirnos a través de la palabra, así como nos unimos territorialmente a través de la geología y el poder de las placas tectónicas. En 2025, la Sociedad Geológica Brasileña iniciará los festejos de sus 80 años y ya tiene en mente devolver esta invitación a la Sociedad Geológica del Perú. Bueno, les presento un poco sobre nuestra Sociedad Brasileña de Geología. Fundada en 1945, actualmente contamos con alrededor de 3.000 miembros. La SBG tiene un centro principal, sede, y 10 oficinas regionales. Nos unimos a través de eventos como el Congreso Brasileño de Geología, eventos temáticos y simposios regionales. Nuestros próximos eventos son el Simpósio Sudamericano de Geología Isotópica, que comenzará el próximo domingo en la ciudad de Búzios, Rio de Janeiro. Espero ver algunos de ustedes aquí. El Congreso Brasileño de Geología tendrá lugar en octubre en la ciudad de Belo Horizonte, importante polo minero del país. Te invito a visitar nuestros sitios. Nuestras comisiones temáticas nos apoyan en el desarrollo de notas, eventos, proyectos y publicaciones. Tenemos la Comisión Brasileña de Estratigrafía, la Comisión de Geología en la Educación Básica, la Comisión de Geoparques y nuestra Comisión de Geoética. Realizamos acciones de equidad y políticas de recepción en nuestras actividades, donde contamos con el apoyo de la Asociación Brasileña de Mujeres en Geociencias a través de la red GeoMamas, que distribuye selos para calificar la recepción de eventos. Te invitamos a visitar nuestro sitio web. Ahora presento algunos aspectos destacados. Nuestras publicaciones están disponibles en nuestro sitio web y en libros a la venta en nuestra tienda o en nuestra publicación de acceso abierto, la revista brasileña de Geología, Brazilian Journal of Geology. Descubra Deriva Continental, nuestro blog de divulgación científica, en colaboración con la revista Super Interesante, donde publicamos textos que abordan los procesos geológicos y sus consecuencias sobre la dinámica terrestre. Tenemos una pestaña para registrar afloramientos educativos en Brasil, además de otras sesiones dedicadas a informar a todas las personas interesadas, como geoitinerarios, geoeducación y un entorno de publicidad de vacantes y oportunidades laborales. Y hemos agregado información útil sobre los cursos de geología en Brasil. Nuestro canal de YouTube inició sus actividades en mayo de 2020 y contamos con más de 200 vídeos de los más variados temas. Actualmente estamos trabajando en el proyecto Geoloque, una convocatoria pública para la selección de propuestas para la popularización de las geociencias. Así como apoyamos casas técnico-científicas para mejorar las políticas públicas a través de la representación ante principales medios de comunicación, así como ante el gobierno y el parlamento. Finalmente, nuestro conjunto de premios busca celebrar y agradecer a las personas que contribuyen significativamente a las geociencias en Brasil. Bueno, fue un placer compartir este momento con la Sociedad Geológica del Perú y todas las personas presentes. Muchas gracias, buenas noches y buena presentación.
Muchas gracias, doctora Elisa, y bien preparada su presentación, incluyendo nuestro logo. Muchas gracias.
Gracias, muchas gracias, sí, Muri.
Entonces, empezamos con la conferencia del doctor Fabricio. Si vemos su pantalla, vemos su presentación.
Sí,
Tendría que
ahora
ponerlo.
pueden escuchar ahora.
Sí.
Ok, funciona entonces. Ok. Entonces, mi español no es muy bueno, no hablo muy buen español, entonces voy a intentar hacer esto en portuñol o un poquito en inglés. Puedes decir si está bueno o no. No estoy viendo mi pantalla. ¿Pueden ver mi screen? Ok.
Sí.
Ok.
Póngalo en modo presentación, sí vemos.
Sí. Okay. So this is the geology of Brazil in the context of South American platform. I teach this course in geology at UFMG in Brazil. So I'm going to try to do this in quickly 45 minutes, if that works, okay? Okay, so you see the next slide now, right? With Professor Almeida. Can you see, right?
No.
Nope. Yeah, that's what I was afraid of. So I'm gonna have to.
Now it's there.
Yeah, I'm gonna have to share the screen, right? So
Sure.
yeah, I'll try with the screen now. Yeah, you seeing it now?
It's okay.
Yes.
Okay, yeah. So yeah, if we talk about the geology of Brazil or South American platform, we have to go through Professor Fernando Almeida, which was one of the greatest geologists in Brazil. And along with colleagues, of course, a lot of what we know about the geology of South American platform was defined in the 60s and before that by Professor Almeida and others. So this is a classic paper from 67, where we can see, this is a figure from the paper, the greatest like tectonic elements of Brazil are already quite well delineated there. They didn't have the names that they have now, but you can see sort of cratonic features there, like the Amazon Craton, which was then called Guaporé, and Brazil Central and Guiana Shield, of course. And we have the San Francisco Craton on the other side, which shape has been like improved over the years, and the orogenic regions here. And a great part of this was done over radar images, like a satellite image that we didn't have a lot of images back there, but they were able to identify structural lineaments. And on top of that, now, can you see the next slide now? The science paper? Okay, just to be sure. Yeah, this is a classic paper from 67 as well, where Professor Almeida is there, along with Professor Cordani, Koji Kawashita, and others from Brazil and from the MIT in the United States, where they got a few samples from northeastern Brazil and from southwestern Africa. And they did lots of potassium argon dates on that. So that was when geochronology came to Brazil and started in the São Paulo, right? And this was quite revolutionary, because at this time, even plate tectonics was kind of still in the beginnings, and this was some kind of test for continental drift, to say that once Brazil, South America, and Africa were joined together, okay? And the black dots there is places where they got really old potassium argon ages in biotite, muscovite, and other minerals. So they got ages around 2.0 to Archean, right? So Paleoproterozoic to Archean. And where is white there? The white dots are ages around 600 million years. So this first potassium argon ages were important to delineate regions of northeastern Brazil and Africa that were affected by some kind of tectonothermal event around 600 to 500 million years, and other regions that were spared of this tectonic event. And now we know that those regions can be identified as old cratonic regions and regions that were affected by the so-called Braziliano orogeny. So in this map here from Cordani and Sato, we have the Andean orogeny for sure, which is in yellow, but the rest of the South American continent will be the South American platform, right? So in this, we have the old cratonic regions, older than 1 billion years, which we can understand as the bricks of the South American platform, the parts that remain rigid in subsequent orogenies. And then we have the green regions here, which were influenced by the Braziliano / Pan-African, because the biggest part of it is in Africa, orogeny, around 600 to 500 million years. And this is like the mortar that binds the cratonic bricks together, okay? So you got some pieces of really old basement that were joined together by this network of mountain belts pertaining to the Braziliano orogeny, okay? And then we got in the clear, like cream color there is the Phanerozoic basins that come after that. So after 500 million years, we don't have any big orogenic event in Brazil. Brazil became landlocked within Gondwana. So after that, you have a huge continental platform that you can fill in with intercratonic basins. That's what happened after that. Okay. So yeah, the meaning of the Brasiliano Pan-African orogeny is that you amalgamated a supercontinent. So everything that's in red there, it's areas that became mountain belts during the Brasiliano Pan-African orogeny, and it culminated in the amalgamation of Gondwana, of the Gondwana paleocontinent. And the South American platform stays like close there until to the late, like early Cretaceous, when you begin to open up the Atlantic Ocean, and then you're gonna separate South America from Africa and all of the other continents and individualize that, okay? Okay, but one thing that's interesting when you look at the map of South America, and this is an idea that's coming from Brito Neves and Fouque and others, is that half of South America shows a quite different geology than the other half. If you look at the Amazon craton, the Amazonian craton, it displays different structural and geochronological and overall different geological evolution than the other half of Brazil, the Atlantic Brazil. And so they propose to separate two different South Americas, right? The Amazonian part of the South American platform. Of course, we're not talking about the Andean belt, but about the South American platform, right? You got the Amazonian South America, which you can argue for an affinity from a Rodinia supercontinent. And you have the non-Amazonian South America, which is the Atlantic part of South America, with the San Francisco Craton and the other minor cratonic blocks that are hidden right now. We should show more like an African affinity. And there are a lot of authors that argue that those paleocontinents like San Francisco and Congo and Kalahari, they were not part of Rodinia. So they will come from different part of it, okay? And that's exactly what happened, like in the various models that you have for the new Proterozoic. You're coming from a paleocontinent that's Rodinia in the beginning of the Tonian, and Rodinia is always pictured as depicted as centering around Laurentia, which is North America in the middle here. And then the fragments of Rodinia start to break apart from Laurentia, and they will turn around the world in a fan-like fashion, and they will meet on the other side, closing around the San Francisco Congo. So this is what Paul Hoffman meant with his 1991 paper, did the breakup of Laurentia turn Gondwana land inside out. So you would be like detaching everyone from Laurentia, and everyone is like coming to meet Gondwana on the other side and leaving Laurentia alone. So that will be the first time that you have Amazonia, because before that, Amazonia is part of Rodinia, coming into contact with the San Francisco Congo, and then you have the South American platform as we know it, at least in the vision of these authors, okay? Okay, but what's so different about Amazonia? Well, there are quite a few attempts to separate the Amazonian provinces in the Craton, and they differ a little bit one from another, but in general, they argue for geological provinces that they become younger toward southwestern Amazonia. So you have the central Amazonia provinces that are older than Archean, okay? And there you have like Carajás and all of the old stuff in the southern Pará state. Then you have the big Maronita Cayunas, which is sometimes called Trans-Amazonian orogeny, which is around 2.2, 1.9. And then you start to be like younger towards the southwestern Craton with the Ventuarita Pajós, which is Orosirian. Then you have Rio Negro Juruena becoming Mesoproterozoic. Then the Rondonian orogeny. And at last you have the Sunsas orogeny around 1.0 billion years. And one sort of understanding of this is that you have Archean seed nuclei, and you have accretionary origins. So arcs, continental arcs, and island arcs that make your Craton grow towards the borders until you reach like the Sunsas orogeny. Because when you reach the Sunsas orogeny, it's interpreted not as an accretionary orogeny, but as a collisional orogeny. With who? With Laurentia. So at this point, Laurentia arrives and collides with Amazonia. So you cannot build another accretionary arc because you have two major Cratons colliding. So that will be the idea that the Sunsas orogeny corresponds to the Grenvillian orogeny of Eastern North America, okay? At least that's some kind of vision there. And before that, before Rodinia, So from the previous paleocontinent, Columbia, to the Rodinia continent, the idea is that you don't have a major reorganization as you have from Rodinia to Gondwana, with all of the blocks going to the other side of the world. But you have like minor reorganization, just Amazonia and Baltica and West Africa just coming from one part of Columbia and then colliding with the eastern half of Laurentia and forming the Gravellian origin. And even before that, you have from Professor Sau and others, and Rogers and others that try to envisage Paleoproterozoic supercontinent, which is sometimes called Columbia, sometimes called Nuna, Paleopangea, or even like Atlantica. That would be, its assembly would happen at 2.1 to 1.0 billion years, which we're going to see that is very important in the South American platform, and its breakup around 1.3, 1.2 billion years. What I think is a huge problem is this kind of reconstruction. When you see the Columbia that's drawn by Zhao and others, you have like everyone again is centering around North America, and then you have South America and Africa, the San Francisco Congo and the West African and Amazon. They are put exactly in the same place that you would expect for the pre-Atlantic reconstruction, like for Gondwana. So I think this is clearly biased, right? It's biased toward our vision of today, how we see South America and Africa today, and in Gondwana and etc. So there's really no way to know right now if South America and Africa, they really were joined together 2 billion years ago, the same way they are joined now. They were joined like 500 million years ago and now. So this is kind of a biased vision that's really, really hard to tell. It's not impossible, but as you can see, like from Rodinia to Gondwana, probably all the fragments, they drifted apart like crazily. We don't know where they came, like margins that collided were not conjugated before rifting. So this would be like a really difficult thing to happen, like these strange attractors that come together in all the same places every time. So yeah, we have to take this with a grain of salt, okay? Oh yeah, so now this is a book by the Brazilian Geological Survey, okay? That can be downloaded for free in their website. And this is quite old by now. It's like 2003, I think. So it's 20 years ago. But there are some interesting figures and discussion there. Of course, a lot of things have developed in the geology of Brazil from then to now, but we can still use some of these figures, especially this SIG figures that they use for the distribution of the geological ages in Brazil are really useful. So we can go, for example, for instance, with the sedimentary covers, we have a really nice distribution of the Cenozoic covers. And we see the big Amazon Solimões basin here, right? Which has some influence from the Andes Fault Belt, so then there's that. And some big other basins like the Pantanal and Bananal Basin, and the huge like Barreiras cover in the Brazilian Atlantic coast, okay? When you go to the Mesozoic, you have the core of the big Phanerozoic basins, the large Phanerozoic basins of Brazil, like the Amazon Basin once again, but also the Parnaíba Basin. And yeah, for sure, the Paraná Basin down there, which is the big, like in deep green, you have the basalts from the opening of the Atlantic Ocean, okay? And then the Paleozoic, you have the sedimentary sequence that fringe the big basins, the large basins. When you go up the tableaus and the ranges that are coming from this section. So you have like Paleozoic section of the Rio do Rastro section here in Santa Catarina, along with others around Brazil. Okay. When you take a look at the Proterozoic basement, we see that new Proterozoic is really important in Brazil. Like all of the structures we see in Google Earth or in satellite imagery, they're clearly new Proterozoic, which is for sure the formation of Gondwana. So the formation of Gondwana was really impressed in the basement of Brazil as the Brazilian orogeny. We have some sort of formation of Rodinia here when the Amazon Craton collided with Laurentia, forming the Gravellian Sonsas origin. But other than that, the Mesoproterozoic is represented by intercratonic basins in the rest of Brazil. And then the Paleoproterozoic, you have the imprint of of the so-called Trans-Amazonian or Minas Bahia origin or Riacian orogenies that may have culminated in the formation of Columbia or Atlantica or whatever you believe that. So you see that the Proterozoic it's marked in the beginning and in the end by important tectonic features, right? And in the middle, you got like either cratonic basins or only in the Sonsaz you have the collision with the Laurentian paleocontinent, okay? And then you have the Archean, which is, of course, more difficult to interpret and to delineate, but you still have like important Neo-Archean stuff around, like in Carajás and in the Quadrilateral Ferrífero region, and Eastern Bahia for sure. Mesoarchean, and then you have the Paleoarchean, which is really sparse, but mainly in the San Francisco Craton area and a little bit in northeastern Brazil that we're going to talk about here. Okay, so talking about each of these geological ages, you got the Hadean and the Archean, which are from the age of the meteorites, the chondrites, around 4.5 billion years to 2.5 billion years ago. And if you join this together, this is close to 45% of all of geological time. And it's kind of crazy to think about it because it's the time window that we know less about it, okay? And in Brazil, like what we got from the Hadean is just one detrital zircon that has been found by this team with Joildo Barbosa and others in Bahia, in Eastern Bahia, where they found in a schist, in a mica schist, which is way younger than this zircon, is around 2.2 billion years or so. They found one detrital zircon around 4.1 billion years. So that will be our Hadean record in South America up to now. So I have to look for more of this stuff. But looking at about rocks, we have in the central San Francisco Craton some rocks that might be Eoarchean, so older than Paleoarchean, right? And those have been found by Professor Elson Oliveira of Unicamp, among others, and we were able to visit it. And when you look at this really old rocks, 3.64 or something, they're actually like some kind of mega enclaves or kilometric enclaves that are within rocks that are much younger. So that's why they are so hard to locate and to interpret, okay? But this is a photo we took in one of these mega gneissic enclaves that has been dated around 3.64. So this is really close to the rocks from Greenland and other stuff like that. And this picture I put in my book that is available in the Brazilian Geological Society website for anyone that want to take a look at that. Professor Elson is here, and we are here visiting. I'm here in the stream left here. We're visiting one of these outcrops that have been dated at 3.64. But almost at the same time, in northeastern Brazil, there was this people here from the Brazilian Geological Survey that found some ultramafic rocks that might reach around 3.7. So they're really close. And this is quite clearly something that has to be investigated in the future, right? So moving to the Paleoarchean, 3.6 or 3.2, we still don't have a lot going on, but we have some records in the San Francisco Craton and also in northeastern Brazil. And this was one of the most famous, this is one of the most famous rocks, which is close to Natal in Rio Grande do Norte, which Elton Dantas and others studied, and they got to 3.5 to 3.4 billion years. So still really old stuff that is hidden in the basement. So you see, that's like 0.4% of all of the Brazilian territory. It's not really representative, but it's really important that's there, okay? When you go to the Mesoarchean, so now we got important stuff around, especially stuff like greenstone belts. So this is a photo of komatiite with spinifax texture from central Brazil, from the Goiás state, in the Alagadinho Corg, so river, right? So this you have in Crixás. And at the same time, you also have in Carajás, in the Neo-Archean, like a bit younger, basins that contain the first huge iron deposits, okay? So this will be around 2.7 billion years or something like that in the Carajás region. That has not only iron for sure, because Carajás has all kinds of metallic stuff that you want, like copper, zinc, or lead, or manganese, whatever you want, you got there. So some kind of mental anomaly or something helped you accumulate those deposits. And it also has gold, right? So it has this gold rush, gold associated with platinum group elements in the 80s that led to this gold rush, and this pictures took by Sebastião Salgado and Alfredo Jarre in the area. So after that, we got the Proterozoic Eon, and now from 2.5 to 538 million years. And once again, this is circa 45% of Earth's history. So if you join the Proterozoic, Archean, and Hadean, that's almost 90% of Earth's history. It's like 88%. So it's crazy that is the part of Earth's history that we know least, but it takes like almost all of Earth's history, okay? And once again, it's important, like interesting that we take a look at this kind of distribution of oxygen and glaciations and biology and etc. And we see that the Proterozoic Eon, it starts with a lot of changes at 2.5, 2.4, and it ends with a lot of changes in 0.5, 0.6 billion years. So that led some authors to say that in the mid-Proterozoic, you have some kind of boring billion or something like that. But we know that's not fair because you had a lot of stuff going on. But indeed, it looks like a bookshelf that you have bookmarkers in the beginning of the Proterozoic and in the end of the Proterozoic, where everything is changing. And no one knows really why, but there are, of course, some ideas of what's going on. But in any case, we got important changes in the tectonics. So you move from the kind of TTG greenstone that we have in Crixás, in Carajás, and all of that, where you have basically TTG terrains and greenstone basins that are coming and squashing together. So you move from that, from some kind of deep subduction, and you really start the supercontinental cycle. So maybe at 2.2 billion years or so, you got the first real supercontinent. Changes in redox state of the atmosphere and oceans. So you have the first great oxidation event at 2.4 or so, 2.2. And then at the end of the Proterozoic, you got the second oxidation event that might be important as well. In climate, in the beginning of the Proterozoic and in the end of the Proterozoic, you got snowball Earth glaciation and you got greenhouse Earth, like extremes in climate going on. Also in biology, like in the beginning of the Proterozoic, you have the advent of the eukaryotes and stuff like that. And at the end, you have the explosion of complex life. So a lot of people try to explain this. And of course, probably all of these spheres are linked together and they are kind of influencing each other here, for sure. Some people talk about a major driver, which should be mantle cooling. So as mantle starts to cool, you can have subduction with plates that can maintain coherence and go deeper down. And then you start producing like eclogites and blue schists and stuff like that. And your mantle belts become taller and longer. And that would influence climate and influence biology and influence the redox state. So that would be a major driver. But some people also talk about an external driver, like an astronomic driver, that in the beginning and in the end of the Proterozoic will be the times that the solar system and Earth along with it would have passed through the arms of the spiral galaxy. And when that happens, you have lots of cosmic radiation coming on, and that will be what was like ultimately driving climate and biology and redox state crazy. So probably have a bunch of factors coming together in the beginning and in the end of the Proterozoic that are causing all of these disturbances in all of these different kinds of spheres, okay? But for us, what matters here is in the beginning of the Paleoproterozoic, we probably got the first true supercontinent, which you can call Columbia or Paleopangea or Nuna or Atlantica, depending on what you believe on. But what's interesting is that if you got the first true supercontinent, then probably you got the first true Wilson cycle. And at the end of this, you got continental freebird that's big enough for the development of large passive margin basins and of intercontinental rift sag basins, which happens at the end of the Paleoproterozoic in the Satyrian. So before that, you probably have like too small of continents, like the TTG Islands. They were too small to allow for the development of a huge passive margin sequence. And the continents are too small for huge intercontinental reef sag basins. You got like some kind of reef basins like the Witwatersrand and stuff like that, but it's really located and it's really not that important as what we had after this, okay? So some kind of huge tectonic change here. And one of the places that we see this is the Iron Quadrangle, the Quadrilateral Ferrífero, which is really close to where I am right now. The blue, really blue shadow speck we see here is the Belo Horizonte city, where you're going to have the Brazilian Geological Congress in October, like everyone is invited. And I'm sitting here right now close to this range. And this has been studied since the 60s because USGS was looking for iron for sure. So this is probably one of the most mapped regions in Brazil. And it has this shape of 4 ranges that are intersecting in a rectangular shape. And it got both gold deposits in the left, which are in the greenstone belts that are Archean, and lots of iron deposits. So all of the hammers there are mines of both gold in the left and iron in the right, okay? And some of the classic interpretations, this is from Fernando Alckmin and Stephen Marshak, is that the Iron Quadrangle would represent one of the first Wilson cycles, okay? So you got drift, you got a big passive margin, the Minas Basin, where you can develop a huge platform where you can deposit the banded iron formation, and you can deposit carbonates, and you can deposit like the fistule passive margin sequence, which look nothing at all like the greenstone belts, with lots of volcanics and lots of gray wax and stuff like that, okay? And of course, you have a volcanic arc that's closing by, so this will be a Wilson cycle that started with the opening of the Minas Basin at 2.5, 2.4 billion years, so that coincides with the Great Oxygenation Event and the first big deposition of banded iron formation. And then you got subduction in the Mineiro Belt at around Siderian to Triassian, and this subduction will bring this arc closer, and this arc would collide with the Minas passive margin basin, would invert it, and that will happen around 2.2 to 2.0 billion years. So at the time, Fernando Alckmin and others, they called this Trans-Amazonian orogeny because it had the same age of orogenic belt in Amazonia. But then other people like Professor Blay Brito Neves from São Paulo, they were against the use of the term Trans-Amazonian because it could imply that Amazonia was together along with this San Francisco Craton at the time, and this is not, we don't really know. So some people now are using the term Minas Bahia orogeny. You could use like Trans Minas Bahia or Trans Bahia or whatever. Or you can use like Triassian orogeny, which is the age of this orogeny if you want to, okay? But the fact is that this orogenic phase, it's, one of the most important orogenic phases in South America and Africa, for sure. So in 2023, we did a survey in all of the Brazilian and African cratons and the fold belts, like the Brasiliano age fold belts with the basement that is reworked there. And all of the provinces have a huge peak. So this is igneous zircon, okay? So like igneous ages of granites and gneisses and stuff like that. And all of the cratons and the basements, they have the huge peak at 2.0, 2.2. So probably this was a very important crucial forming event in South America and Africa, okay? And it could have resulted in the formation of a supercontinent called Atlantica or Colombia or Nuna, depending on who you're talking to. Once again, I think the major problem with this kind of reconstruction is that you can see that the Amazonian Craton and the San Francisco and Congo Craton, they're drawn approximately in the same place that they will be nowadays, like in Gondwana. So this has some kind of load, some kind of bias from what we expect to see today. So if you believe that from Rodinia to Gondwana, the Amazonian Craton is in a position that's really different from the San Francisco Congo, then there's no reason why to believe that they come together in the same place in Colombia in 2 billion years ago. So that's something to think about. Okay, but in any case, if you got Columbia or Nuna or whatever, after that, you got a huge paleocontinental mass for the first time. And the Earth, the planet, is trying to lose heat all the time. So a huge paleocontinental mass is a problem. It's like a lid that you're putting over a hot pot or something like that. So it starts to break apart, to try to break apart as soon as it forms, okay? So the result is that you got lots of rich sag basins. So it begins to crack and to be filled with clastic sedimentary rocks in systems that you have both in the San Francisco Craton, like the Chapada Diamantina, Espinhaço, and the Chapada dos Veadeiros in the western part of the Craton, and also in the Amazon Craton, everywhere. Okay, so both in central Brazil and in the Roraima block there. So in this book from 2017, from Monica Hybron and others, you got one of the most beautiful landscapes in Brazil, which is the Chapada Diamantina region, which is part of this rift sag Proterozoic basins that you have some kind of huge paleocontinent trying to break apart. So in Diamantina, this is really famous, and it was studied when the royal family came from Portugal to Brazil. It was a kind of a odd situation. I think maybe one of the only times that a royal family came to a colony and tried to stabilize here because Napoleon was invading there, so they invaded here. And they brought together lots of German and other kind of European explorers. And one of them was Wilhelm Schwegg, which kind of did some of the first geological mapping and geological profiles on horseback. So this profile here is from Diamantina in Minas Gerais to Rio de Janeiro. And one thing that's amazing is he got the strike and dip right. If you do this profile today, you see that all of the geological layers are dipping towards the Atlantic Ocean. So this is right. And we got this town in Minas Gerais, which is called Diamantina, where we got a geology center there. It's called Geology Center Schwegg, which you still do geological training for mapping there, okay? So it's part of my university. And also in the Chapada dos Veadeiros, which is the western part, you got this kind of huge rift sequence that lots of sandstones and conglomerates and all the classic stuff that's really resistant to erosion. So that gives you like beautiful landscapes because everything else erodes and you have huge ranges and tableaus and stuff like that and waterfalls. So that's really beautiful. And in the Chapada Diamantina region, where I bring my students every year to talk about this kind of situation there. You even got a training center for the Brazilian Geological Survey, which is in the Chapada Diamantina as well. So it's nice to bring students there to map. And for sure, you can take a look at the beautiful landscapes as well. Okay, and also involved in this rift sag basins, you probably got fractures that go all the way down the mantle, right? And then if you go all the way down the mantle, you have the possibility to sample kimberlites and alkaline rocks that might bring you diamonds and other stuff that's interesting. So Von Spix and Von Martius, they're, if I believe, Dutch. I don't remember well, but they're also brought by the Portuguese crown to study Brazil and stuff. And all of them talk about diamond exploration in the region of Diamantina. And this is one of the main source rocks, which is a conglomerate called Sopa Brumadinho. Sopa means soup, right? So it looks like a soup because it's a conglomerate. No one ever found the kimberlites, okay? No one knows the how it looks, like what is the primary rock, because the diamonds are taken from the secondary sources, which are the detrital rocks, so placer diamonds, okay? So yeah, this is a classic outcrop that everyone that does geology in our university goes as well. And also in the Chapada Diamantina region, you have the Serrano, where you have the Tombador conglomerate. It's the same, you got diamonds there as well. And of course, you got stuff all the way up in the Amazonian Craton. So this is the Monte Roraima, which is really famous. It's part in Venezuela and part in Brazil. It's part of the same kind of rift sag basins that we got everywhere. Okay, so now moving to the Neoproterozoic. Some really important stuff is going on here. You're going to break up Rodinia in the Tonian at around 1.0 to 900 million years. during the cryogenian, the Rhodinian fragments are drifting around, and they're going to meet around in the other side of the world, in the Ediacaran, when they are rejoining Gondwana. So all of the cratons that are rifting from Laurentia there, they're going to have passive margins that are going to be open to the global sea in a critical moment of Earth's history, which is the cryogenian. And what happened during the cryogenian is that you almost froze up the planet completely, at least 2 times, right? So that you got the snowball arc glaciations here that are represented throughout South America. And you have some beautiful examples like this striated pavement, which is published by Isota et al. In 1969, which is in Minas Gerais state. And I'm here looking at some of the striated rocks, and they are over ripple marks here. And here's Lucas Warren, also laid out in the striated pavement. So this is one of the best examples of Precambrian glaciation in Brazil. And in Bahia, in the Chapada Diamantina, you got drop stones, so that could convince people that you had icebergs that were melting during the snowball earth. And also, this is in Corumbá, in western Brazil. You got banded iron formation because the banded iron formations came back during the snowball earth, the glaciation, because of the you were kind of separating atmosphere and ocean. And then the ocean can become anoxic and concentrate iron again. But when the ice melts, the oxygen comes in and it interacts with the iron and deposits it really quickly. So at the same time that you're depositing banded iron formations, you might have icebergs that carried like big gneiss and big granite boulders, and they let the boulders down. So this is a banded iron formation with the boulder, with a drop stone, like a huge drop stone here of gneiss, which is in a mine from Vale in Corumbá, okay? And on top of that, which is really crazy for the new Proterozoic, you got the glacials, and now is on top of the glacials, you got the carbonates, which are deposited in hot climates, because after the deglaciation, you have some really strong greenhouse effect, and then all of the alkalinity and all of the CO2 are going to go through the water and deposit carbonates that sometimes they have, like here in this instance that I'm here with Professor Maoyan Zhu from China, aragonite fans. This means that the water was really like super saturated in calcium carbonate, and it started to precipitate carbonate crystals on the sea floor. Like it was so full of carbonates that if you take a swim at this time, you would step on the carbonate crystals and you would hurt your feet. So this is like the experiment we do with in the mineralogy classes, where you crystallize something from a glass of water or something like that. Okay, so what happens here, and this is from our paper in 2023, is that you're getting fragments from Rhodinian and colliding them with the African fragments. And then you're closing these cryogenian basins where you have the glacials and stuff like that. And all of these oceanic basins, they are becoming the site of mountain belts. So now you're getting to the Ediacaran and forming Gondwana, which is the last slide here, okay? So that's what happened from around 600 and something to 500 million years. And then you're gonna build the huge orogenic regions of Brazil, like the South Atlantic, which is classically called Mantiqueira province. And you have northeastern Brazil, which is called Borborema province. And you have central Brazil. And of course, all of this continues into Africa. So we are left with only part of this mountain belt system that has, like, if you can read from the image, it has everything you need for a complete Wilson cycle, like ophiolites and arc systems and collisional systems and everything you would expect. So you can read from the original papers because we don't have a lot of time here to describe. But of course, all of the granitic regions that you see in Brazil, like in southeastern Brazil, when you had, the opening of the South Atlantic, all of the shoulders of the rifts, they came up. So when you go, for example, from Belo Horizonte to Rio de Janeiro, you're doing a section that you're going down the crust. You go from really shallow crust towards 5 to 10 kilometers. So you go into green schist, then a fibolite. And then when you get to Rio de Janeiro, you are in the granulite phases, and you are about 30 kilometers deep, because that's the part that really went up when you are opening the Atlantic. And then you got like the core of the orogenic system, where you're going to have all of the granites and gneisses and migmatites. So if you go to the beautiful landscape of Rio de Janeiro, you got granites around 560 million years that all come from the melting of everything else in the orogenic core. Okay, so this is the Pão de Açúcar and Corcovado from the book of Luizão Silva. It's been dated by quite a few people, so okay. And what's really interesting is at the same time, so in pink here is the orogenic regions where you got the granites and stuff like that. Stars are high pressure rocks like eclogites, blue schists and stuff like that. And in black is the cratonic basements, and in blue is the foreland basins, okay, that are forming due to the formation of these fold belts. And what's really interesting is in all of these Ediacaran, Cambrian, foreland basins, you got for the first time the imprinting of complex life forms, right? Like Claudinas and Corumbellas, which are skeletal forms, so the first biomineralizing organisms, but also soft-bodied organisms, like you can see here this leaf frond, looks like a leaf, but it's called Dickinsonia, and it's being interpreted to be one of the first animals on the base that it got cholesterol. So there's a Russian guy, Ilya Bobrovsky, that was able to crush this and analyze this kind of fossil, and he found cholesterol, and cholesterol is typical of animals. So this could be some of the first animals that appeared right in the time that you got the first huge mountain belts, like continuous. So that's something that we are investigating, and this is part of our project, Mountain Belts and the Inception of Life on Earth. It's called Mobile, and then you can take a look at that in on our social media and in our websites. We try to interpret why this huge mountain belts could have an effect on the foreland bases around, the biogeochemical situation on the foreland basements that could help the complex life forms to thrive. So one thing that they could do is like the higher mountain belt, the faster it consumes CO2, because weathering consumes CO2. Okay, so when you're consuming CO2, you're modulating the climate. At the same time, you're burning part of the carbon. And when you bury part of the carbon, part of the oxygen of the CO2 is free to accumulate in the atmosphere. So if you have high mountain belts, at once you can have like modulated climate and a surplus of oxygen, which might help complex life forms to thrive. And also, if you're weathering mountain belts, you can have a lot of bionutrients that are being delivered to your foreland basins, like phosphorus, selenium, molybdenum, and others. So that could help as well to develop this kind of complex life forms. Okay, so now moving to the Phanerozoic, which is around 12% of Earth's history. But as you can see, now the chronostratigraphic situation, it becomes really detailed, because now is where you got fossils, like macrofossils, so you can subdivide that really well. But in true, that's only 12% of all of Earth's history, okay? And what you have in Brazil is that you're now locked within Gondwana, okay? So we have a huge continental platform that on top of that, you're gonna develop intercontinental basins, okay? That are not only part of Brazil, but they continue into Africa and into the other continents of Gondwana. So in this case, is the Bacia do Paraná, which is the big one here in southern Brazil, and Paraguay and parts of Argentina, Uruguay, and others. That also continues in Namibia. And this photo is from the Serra do Rio do Rastro in Santa Catarina. And yeah, the Paraná Basin and other basins that are intercratonic during the Phanerozoic in Brazil are really interesting, because they got the Gondwana rocks, which were used by Alexander Dutoit and Wagner and others to interpret that once the southern hemisphere continents were joined together. So you got Permo-Carboniferous glaciers that you can find them in South America and in Africa and in Australia, in India, and a big surprise was Antarctica. Like everything was found in Antarctica as well. So you can use that to try to interpret former connection. And you got coal deposits everywhere. And you got fossils of this Permian 1 meter long reptile, which is called Mesosaurus. okay, which people argue that you wouldn't be able to swim through all of the South Atlantic if South America and Africa weren't joined together someday. So this was used as evidence as well. And Glossopteris plant fossils. And at last, you got the broad basaltic lava flows at circa 130 million years that mark the demise of South America and Africa and the breakup of Gondwana at last and the opening of the South Atlantic Ocean. So all of this was used as evidence for former connection between South America and Africa. This is some of the glacial rocks, okay? So it's me in Calembre in Piauí, northeastern Brazil. So it's a striated pavement of the Permo-Carboniferous glaciation. And also a famous varvate, okay? Glacial rocks with dropstones in Itu, São Paulo. And at the end of the, like in the Cretaceous, you got basaltic lava flows, which are really big and everywhere. This is a photo from Torres, Rio Grande do Sul, where the basaltic lava flows reach the Atlantic Oceans, okay? And they continue to the other side at the Neca Plateau in Namibia. And there's some interesting photos of places that we mapped. This is the geologist Ildor, and you got the basalt columns there, but they are kind of horizontal and going sideways because this is a lava conduit, okay? And here is pillow lavas. The pillow lavas are somewhere. You got the lava flows coming in a lake or something like that, so they start to form pillows.
You
Okay.
can keep those guns in a safe place.
Oops, got something you wanna... Sorry? Okay. Okay, so yeah, on top of that, in the Cretaceous, you got lots of dinosaurs and stuff like that. So this is living Ivor Price with a huge femur from I think someone, yeah, I got it. Okay. So I urge everyone to visit the Peirópolis Dinosaur Park in Minas Gerais, which is got some really nice dinosaur bones. Okay, so after that, in the Cretaceous, so the huge lava flows mark the opening of the Atlantic Ocean, and then you got the coastal basins of Brazil, which they open up in a zipper-like fashion. They don't open up all at once, but they have a diachronous opening. This is really important because you develop a phase that you have restricted basins, like Gulf basins. This will be very important because this is where you develop salt, like evaporite basins. So you have those swamps, like Cretaceous swamps with lots of dinosaurs and primary producers and stuff, and really black shales and stuff like that. And on top of that, you got a Gulf phase where you're gonna have the seal. Okay, so you got the source rocks, the seal, and then for a long time, people used to explore what's on top of that, which is the drift phase where you got turbidites and stuff like that, until you develop the engineering that was sufficient for you to drill below the pre-salt and then get the oil from there. And one thing that's interesting, like the first oil field in Brazil to be explored, like the first oil rig, was in the Recôncavo Basin, right? And in the Recôncavo Basin, sort of, you don't have the drift phase, you only have the rift phase. So sort of saying that the first oil rig in Brazil was in the pre-salt, but in a basin that you don't have the salt. You just have the rift phasing, okay? So yeah, all of the basins in the coastal Brazil, you can have a pre-rift phase, like in the case of Pelotas there, but for the other basins, you have seam rift, which you're gonna have the swamps and stuff like that, where you have the source rocks. Then you have a salt phase that's really important, where you have the transitional phase with deposits of evaporites. And on top of that, you got a transgressive marine phase and a regressive marine phase. And for a long time, oil was explored in the transgressive regressive section, looking for the seals in the turbidites and the place that are the sandstones within the turbidite muds, until you have engineering that's good enough so you can drill through the salt and get to the source rocks directly, okay? So to finish this, we got the Cenozoic in Brazil, where you got sedimentation in rifts, like the Southeastern Continental Rift, interior basins, and marginal basins. And also you got important volcanism in the northeastern Brazil and Atlantic Islands. So you got some inland volcanism, like in Natal and Rio Grande do Norte, and in Pernambuco, but also in the Atlantic Islands that probably coming from the mantle, some sort of activity like that. So this is a field trip we did to the Fernando de Noronha Islands, which is off the coast in northeastern Brazil. And there you got some interesting basanites and also pyroclastic rocks. And I'm holding here a piece of mantle xenolite, like really olivine rich within this basanite sample here. And in this place, for example, we got pyroclastic flows and you got basanite lava flows. And those are around 16 million years to almost present. So really young stuff there, okay? Also, to finish up, we got in the coastal Brazil, the formation of the barreiras, sometimes called formation, sometimes called group. Is really not well studied. So, but one thing that's interesting is that these barriers, like the colored barriers that go from Rio de Janeiro all the way to Bahia, all the way to Belém, to the northern Brazil, they were described, like we don't need to read the whole thing, but they are described in the letter of Pedro Vaz de Caminha in May 1500. So the Portuguese, when they, you can say, invaded or arrived or whatever, when they saw Brazil for the first time, Pedro Vaz de Caminha used this name barrier. So it's probably one of the oldest stratigraphic names from the Brazilian geology, okay? And they're composed of sandstones and conglomerates that are alluvial fans. And sometimes people interpret that could be some kind of marine incursion as well. But what's important here is that we probably have some kind of climatic influence, like the Antarctic ice sheet growing and becoming smaller. And then you have the sea coming up and down, but also kind of neotectonic importance. I had a student, a PhD student, that used to go to the field with a shovel and then just shovel up some part of the barreiras, and he used to find normal faults and stuff like that with stria. So you have movements going on, okay? Yes, this is so some of the part of the sediments, so really interested sediments, like cross-bedded sandstones and conglomerates and massive sandstones and purple rocks and mudstones. And we studied this a little bit. They go from 23 to around 1.8 million years. So really recent stuff. Every year I take my students there because it's really nice. And then to finish up, like in the same place here in Arraial da Ajuda, Bahia, Brazil, we got beach rocks. Oh, these rocks, they kind of call vulgarly of reefs, but they're not reefs. They're sandstones that are cemented by carbonation, like carbonates, okay? And this is probably some of the youngest rocks in Brazil. They're not sediments, they are really rocks because they've been cemented because of the interplay between salt water and fresh water. Right? Salt water goes up and down. And in this place here, we got some coral reefs that they needed like 3 meters of water to develop. They are now dead. So probably the seawater level was about at least 3 meters above what's right now around 6,000 years ago. And when it came down, the freshwater lances kind of interacted with the salt water and cemented the rocks. So with this, we go from 3.64, which is the gneiss we see in Bahia, to the youngest rocks in Brazil, which is about 6,000 years old, okay? So I hope with this, we had a good flash view with the time we had of the geology of Brazil and how we can interpret that in the supercontinental cycles and stuff like that. There is this last slide with the informes, right? My email here. I teach at UFMG, on Project Mobile. I'm part of Instituto Geoatlântico. We're supported by Instituto Serra Pilheira and CNPq. I have a YouTube channel as well, and here's some Instagram, Facebook, TikTok. We have a Instagram for Instituto Geoatlântico, which is really nice. People are always posting there, and we have like 70 researchers and 17 institutions. for the project mobile, which is GeoLife Mobile. And I have a new one, which is Essa é Nossa Terra, Esta es Nuestra Terra, where I try to post short videos for the geology of the places we visit. So this is where I've been posting more nowadays. So I have this YouTube channel here. It's youtube.com/my name. And this Esta es Nuestra Tierra, especially in Instagram, of people that like TikTok can go through TikTok and see this 1 minute short videos there. Okay. Yeah. So with this, I would like to thank you very much. And this is the last slide. Okay.
Thanks very much, Dr. Fabricio. Muchas gracias por su conferencia. Tengo una pregunta en particular, si nos puede comentar un poco sobre este tema de las ocurrencias de hidrocarburos que hay al noreste de Brasil hacia Guyanas. Esto, ¿cómo es el contexto geológico para la ocurrencia de estos hidrocarburos que hay? No sé si tiene información al respecto.
This is for the passive margin basins or for intermittent?
My question is about we have learned about on the news that there's a bunch of potential of
Yes.
oil camps or fields towards the northeast of Brazil, towards the Guyanas. So if you can give us some comments about the geological context of that area, it would be great.
Yeah, so I'm not really sure if I know these occurrences, but from northeastern Brazil to Guyana, what you have, like inland, you have the Craton, right? The Amazonian Craton. And in the passive margin, you got the passive margin basins as well. So I know there are some people looking for hydrogen, right? And stuff like that, gas in the northern Brazil, but I'm not really sure about the context of this occurrence. I'm sorry that I cannot help more on this.
Okay, no problem. Thank you.
Okay.
Vamos a revisar algunas otras preguntas, por favor. Sí, hay una consulta del ingeniero Ernesto Álvarez y hace preguntas si puede hacer la pregunta por micrófono, es decir, en audio. No sé si Alicia nos permite con eso, por favor.
Sí, ingeniero. A ver, vamos a ver. Dos personas están levantando la mano. Los vamos a dar. Ya. A Miguel Uribe se le habilitó el audio.
Le habilitó el audio al colega Ernesto Álvarez.
A ver.
O
Sí.
Miguel Uribe también, sí.
Sí, a ambos ya está habilitado su audio. Perfecto. De Ernesto Álvarez ya está habilitado. Adelante, Ernesto.
Buenas noches, ¿me escucha?
Sí.
Sí, le escuchamos.
Buenas noches, ingeniero Magic. Parabéns pela sua apresentação. I have two questions related to economic geology. One of them is that what do you think about the relationship, special relationship between the granitic zinc in Rondonia and the Bolivia Potosí zinc? The age of Rondonia is, I think, Paleoproterozoic, and in Bolivia it is Miocene. So the occurrence of zinc are especially related, but I don't know the difference of age or what happened in this part. Do you know something about that?
Yeah, okay. I don't know specifically these deposits, but a lot of deposits in the Amazonian Craton, what we see, and I have a colleague that is kind of defending this now, it's really hard to pinpoint age of mineralization. So sometimes you have like gold deposits or copper or whatever that they form, let's say, in the Archean, but then you have events in the Cambrian that mobilize the fluids, and then you have some kind of enrichment of the deposits. So it's really hard to say, like, when you say the age of mineralization, what we are talking about. You're talking about the first age of formation, or the age that the fluids remobilizate the metals and concentrate that somewhere else. So I have some colleagues right now that they're kind of defending that you don't have a single age of mineralization. You have different ages of mineralization in a system, that you can even have a final concentration age that would be like supergene or something like that. That's really recent, like during the formation of the landscapes or something like that. So we have this kind of situation both in Carajás, where you have like the IOCG deposits and some kind of older deposits that have been remobilized during events that come later. And also in the Quadrilateral Ferrífero, like most of the gold deposits, especially in the eastern area, they seem to have been formed during the Archean, but they have been remobilized in the Cambrian 2 billion years later. So it depends on where you are in the Amazon Craton. Maybe if you are in Rondônia, you are in the different border or situation than Bolivia. And then you have some kind of remobilization that was going on in Bolivia that you cannot detect in Rondônia. I would kind of guess something like that, even though I don't know the deposits myself. Okay, and I also didn't talk about this because I didn't have time, but there are a lot of like in the Amazon Craton for sure, you have intercontinental remobilization events that kind of mess up the deposits. So I don't know if that helped with your question.
Okay, thank you. And the second one is maybe it's a basic question for you, but why pegmatites, rich lithium pegmatites with zinc, tantalum, and niobium are in the Archean to Cambrian age? Why is about the depth, the pressure, and could you explain what happens in Minas Gerais and in the Borborema about the pegmatites?
Okay. Yeah, so at least in Minas Gerais, which is the ones I know, and I'm working with people there right now, you are in the final stage of orogenic formation. So you already have a huge mountain belt, and it's so big that it starts to crumble in its own weight, like it starts to fall apart. And then when that happens, the asthenosphere, the mantle, it comes up and heats up the crust. And when it heats up the crust, it starts to melt everything around. So when you're melting everything in the orogenic core, you melt all of the sedimentary rocks and stuff, you're gonna have post-collisional anorogenic granites that they kind of are getting all of the elements that wouldn't otherwise get into minerals. So you're in the really ultra differentiated part of the plutonic bodies, where you got liquids and gas and stuff like that that are going around and collecting all of the elements that wouldn't otherwise form minerals. And that's why you have like all kind of tourmaline and all kind of gems and stuff like that. And along that, you can have sometimes lithium. But on my understanding, it depends also on the metamorphic window that you are. You have a specific metamorphic window in the mid range of pressures and heat and stuff, that if you melt stuff in that window and they have the specific chemical composition that you need, like the mica schists have the chemical composition that you need to accumulate lithium, then you can be in the window, in the right window to accumulate lithium-rich pegmatites. So I believe that happened in both Northeastern and Minas Gerais, but it's not everywhere and every time that you're going to have this specific window of chemical and pressure and temperature and enough like mica schists that are rich in this kind of elements in the first place that you can accumulate them. So I think it's a matter of specific lithium. There are a specific window for this kind of situation. Okay.
Okay, Professor Fabricio, thank you very much. Gracias, ingeniero Mori.
Muchas gracias, colega Ernesto Álvarez. Creo que teníamos participación de otros colegas levantando la mano. Nos confirma Alicia, por favor. Rolando Cruzado.
Perfecto. Adelante, ingeniero Rolando. Ya está habilitado su micro. Ingeniero, su micro aparece como prendido, pero todavía no lo escuchamos.
Está sin audio, Rolando. Quizá pueda prenderlo.
Ingeniero Rolando, tal vez nos pueda confirmar si es que nos escucha. Su audio aparece como encendido, pero creo que tiene problemas de audio.
Quizá Rolando pueda escribir su pregunta, su consulta.
Bueno, mientras agradezco mucho a todos vosotros, Bedrick, Alicia, Elisa, Nelly, muchas gracias. La próxima vez voy a intentar hablar español.
No, no hay problema,
Tengo que
doctor Fabricio.
aprenderlo.
No hay problema.
Pienso que temos que combinar, hacer trabajo de campo, discusiones de campo y también conferencias juntos para poder trocar las informaciones.
Por supuesto. Bueno, vamos a esperar a ver si logra enviar su pregunta a Rolando Cruzado, por favor, y si no, pasamos a la siguiente etapa, por la hora también, que es la entrega del certificado. Enviamos normalmente un certificado por la participación, doctor Fabricio, y entonces eso es para dar también el agradecimiento por su participación en esta conferencia. We send you a certificate, a digital certificate to you, and thanks for your participation on this conference. It was really great to learn about the geology entirely for Brazil. There's certainly a bunch of other questions that if we can collect later on, we can send it out to you on email probably, so we can have a reply from you. Thanks a lot. Y no sé si puede Alicia proyectarle el certificado como para compartir. This is the certificate for Dr. Fabricio de Andrade. Thanks a lot for your contribution to this, to our Society of Geología del Perú, Sociedad Geológica del Perú, and for also having all of you celebrating our century here as a society. Thanks a lot. Muchas gracias por su participación por estos 100 años de la Sociedad Geológica del Perú. Y este es un certificado de reconocimiento para el doctor Fabricio por su exposición importante. Y bueno, vamos a invitarlos y los vamos a informar sobre nuestras siguientes actividades que tenemos en la sociedad, y siempre con la doctora Elisa y la doctora Nelly para compartir también proyectos de comunión con nuestra sociedad y ver si podemos desarrollar actividades juntas de difusión de las ciencias de la Tierra, de la geología, y cómo esto conversa con nuestra geología a nivel de país también, ¿sí? Muchas gracias.
Gracias a todos.
Sí.
Buenas noches.
Buenas noches. Quiero, antes de terminar, compartirles que también vamos a tener sesiones de este tipo en los próximos meses. Vamos a intentar hacer uno por mes sobre geología de los otros países en Sudamérica, Latinoamérica. Y entonces van a estar invitados a sus correos y a sus WhatsApp también sobre nuestras conferencias más adelante. Muchísimas gracias a la doctora Elisa, a la doctora Nelly, al doctor Fabricio. Thanks a lot for your contribution, and we're glad to see you later in our events somehow.
Agradezco una vez más a toda la Sociedad Geológica del Perú por la invitación para que sigamos conectados al servicio de las geociencias. Espero que la próxima reunión sea pronto. Muchas gracias. Buenas noches.
Muchas gracias, doctora. Buenas noches. Gracias a ustedes. Muy buenas noches, ¿eh?
Gracias, gracias.
Muchas gracias. Gracias, nos vemos.
Gracias, besos, abrazos.
Abrazos.